Hey everyone, welcome back to my channel AK Coding. Today we will discuss a very important topic of DSA, that is space and time complexity analysis. Whether you are preparing for coding interview or improving your DSA skill, then stick around. At the end of this video, you have clear picture of space and time complexity analysis, and that will help you to design efficient algorithm. Let's dive right into it. There is two key concepts for the algorithm analysis. Number one, time complexity, and number two, space complexity. In computer science, there is a two term used for analyze an algorithm, that is called time complexity and space complexity. Right? So the time complexity is basically responsible to analyze the performance of an algorithm, and space complexity is responsible to analyze memory used by your algorithm. Let's discuss one by one. What is time complexity? To understand time complexity, we have to understand actual runtime. What is actual runtime and what is runtime? Right. So when we design an algorithm, and it's a time to recheck your program, that how efficient you have designed your algorithm and how much memory is required to run your program. So there's a two thing. One is memory required to execute your program, and number two, how much time is required to execute your program. Right? So this is actually runtime. But the problem is runtime differs based on several multiple factors, like programming language which you are using that particular algorithm. Let's suppose you have written program into C++, then obviously it would be the faster than Python, because C++ is very low level programming language, whereas Python is high level programming language. So there is a very difference between C++ and Python. That's why the runtime will be deferred when we choose different programming language. But we require to analyze a time complexity program that is absolute, that is not dependent on programming languages, right? What is the next factor? There is a code implementation. As you write your program, the way you write your program, that impact the performance of an algorithm, right? Number third, that is compiler and interpreter. Compiler and interpreter is also play a crucial role in the performance of your program. Number fourth, hardware performance. If you are running your program in your computer and your computer is high resource, meaning high processing power and latest CPU, then your program will run faster than older configurations of the hardwares. Number third, that is operating system and background task. Number sixth, input size and data complexity. Right, so these are multiple factors that impact the performance of your program. So question is, then how can we analyze our program that is independent to the programming languages, code implementation, compiler and interpreter, hardware performance, operating system, right? So So to solve this problem, there is a one concept come into computer science, that is asymptotic annotation, right? So let's understand asymptotic annotation. To understand asymptotic annotation, we have to take an example, right? Let's find a smallest number in an array, right? To do this, we have to compare each number in an array. If array is 100 numbers, meaning if array size is 100, then we need to 100 comparisons. If the size of an array increases up to 5000, then we need to compare 5000 times to find the smallest number in an array. Why this is matter? Well, when we working with a small amount of data, then it might not notice the performance differences, but when size grows to the millions and billions of element, then it matters, right? Let's suppose you have designed an algorithm which is more optimized, and it will take very less time to do a specific job, right? And when any user will request to your system, it will give response in millisecond, then it is very much user friendly, and the system is capable to execute or perform any job in certain amount of time, right? And if your program is optimized with a space complexity, meaning your program is take a very less amount of memory to execute your program, right? In that case, the cost of your program, your system will be reduced. Number third, let's suppose if your program is more on the optimized state where time and memory come less, in that case the possibility of the crash you may consider as a out of memory. If your program is taking huge amount of memory, then there is a possibility to crash your system. So all these terms, all these three concepts, that is a time, cost and crashes, might not happen if your program is optimized. Now let's discuss time complexity calculation with examples. Number one, constant time. If an algorithm takes same number of operations no matter how large the input size is, that is called O of 1 complexity. O of 1 meaning it is constant time. Let's suppose we access an element in an array like this. So how much size of your array, it will not matter. It always require to one operation to get that job done. In that case, in that case, constant time, that is O of 1, is required. Moving forward, linear time. If in if the number of operation increases linearly with the input size, the time complexity will be O of n. Let's take an example. Find the minimum number in an array. If we find the smallest number in an array, we required a for loop that will iterate through your array and compare the value with minimum number, and it will find the minimum or smallest number in your array. So to do this job, it required to iterate whole element of an array. As number of element increases, the iterations will be also increasing. So in this case, the linear time is required to traverse whole array. Here in calculation you can see the loop runs n minus 1 times, but we ignore constant, so the time complexity is O of n. If n is 100, the loop runs 100 times, and if n is 5000, then it required 5000 times. Moving forward, algorithmic times O of log n. If an algorithm reduces the problem size in half in each steps, it has O of log n time. Example, binary search. The binary search is a technique where it will uh, reduce the problem into half in each steps, right? Here you can see it. Here you can see on the each step it will reduce in problem into half. In that such type of problem, the algorithm time, that is O of log n, are required, right? Here in calculation you can see each step have the search space of log n step. If n is 1000, then instead of 1000 operations, that is O of n, binary search take only log of 1000 equal to 10 operations only. This is super efficient compared to O of n. Now O of n square, quadratic time. When an algorithm have nested loop, the operation multiplies, leading to O of n square time complexity. Example, checking duplicate pair in an array. Moving forward, here you can see the calculation of the quadratic time. Factorial time, which is very slow and it is not impractical, so ignore or always ignore this kind of implementation. That is that will take huge amount of time, right? Here you in calculation you can see if n is 5, then it will require 120 operations, and if size increases to 10, then is then it will skyrocket, then it will reach to, so it is impractical in large input size. Here let's see the summary. Constant time is super fast, and we always welcome such type of algorithm implementation. Number 2, O of log n, which is in the case of binary search, it is efficient. We can consider as a good algorithm implementation. Number 3, that is O of n, that is a linear time. When we finding min and max element in an array, it is acceptable. O of n log n, which is log linear time, it is basically in case of merge sort and quick sort, that is a balance. We can consider it in some scenarios. O of n square, that is a quadratic. Nested loop iteration, that is a bubble sort, this is a slow. Exponential time, that is a O of 2k power n. In case of Fibonacci series, it is very slow. O of factorial n generated are the permutation unacceptable in large inputs of data. Now moving forward, let's see the visual representation of time complexity chart. Here you can see this chart represent constant time. This represent the O of log n, that is algorithmic time. This represent the linear time, that is O of n. This chart represent log linear time, that is O of n log n. This represent the quadratic time, that is O of n square. This chart represent the exponential time, that is 2k power O of 2k power n. This is a factorial time. We always avoid this algorithm implementation, exponential time and quadratic time. This is okay, you can consider it in some scenario. This is also better, but constant time is best and algorithmic time is also good for a good programming design. Now let's see what is space complexity. The space complexity is the amount of an memory an algorithm required to run as a function of its input size n. Meaning, when we are designing an algorithm, the amount of memory is required to execute that program, that algorithm, that is called space complexity, right? The formula here you can see, total space is equal to fixed space plus dynamic space size. Don't worry, we will discuss with the help of example that will give a clear picture. What is different between time complexity and space complexity? Well, the measure of the amount of time an algorithm takes to run a function of input size n is called time complexity, meaning it is basically to calculate time of an algorithm, whereas measuring amount of memory of an algorithm required to execute a function of input size n is called space complexity, meaning how much memory is required to execute a program. In that case, we calculate the space complexity. But when we require the how much time to complete job of how much time is required to complete a job, that is called time complexity. Now let's understand space complexity with the help of example. Here we will understand constant space time, that is O of 1. Here we have taken an example, that is print sum, that accept two input value number 1 a and b. In the body of this function, it will return the sum of a and b. Here we have printed the sum value, right? So a and b will be always constant or always fixed. So the the space complexity would be O of 1. Now let's take second use case, that is linear space, that is O of n time space complexity. Here we have taken an example to create an array with help of a function. Here is a one function, that is a create array, and it will take input value n, and we are creating new object of an array based on the input size, right? So the the size of an array is directly related to input size. So here n is variable, so that's why the space complexity of this program would be O of n. That's it. If you found this video helpful, don't forget to like, share and subscribe for more awesome tech insight videos. We'll see you in next video. Until then, keep coding and stay curious.